We're good. Great. So it's a great pleasure tonight to introduce Ray Ozzie. Ray will sort of go through his career with you, so I won't labor it here. But the really important thing is he's been doing collaborative software since he was an undergraduate at the University of Illinois in the 1970s, where Plato was really the sort of granddaddy of all the collaboration and computerized learning systems. So Ray has gone through a number of jobs in Lotus and out of Lotus in startups. 2 years ago or so, Microsoft acquired Groove, which is his most recent startup, and he became one of the CTOs at Microsoft, and recently was named Chief Software Architect title. So thanks for being here tonight.
Yep.
Nice.
Thanks. To be here. Thanks for coming. Glad I made it. Traffic was a little sketchy. So what I thought I would do is just more or less give you a walkthrough of my career, basically, and just tell some stories about what happened starting in when I was back at school, because I think at least my perspective on collaborative software and collaboration is, essentially heavily weighted by the experiences that I've had, and maybe you'll see some of my perspectives because of those experiences. I would really, really appreciate it if you would just interrupt me if you've got something that you want me to go deeper on or riff on, and otherwise I'll just keep plugging away at it. So anyway, this kind of gives the high-level view of what I'm going to step through. I was an undergrad at University of Illinois, and then I went off to Data General, which I'll talk about, which was at the time a fairly an up-and-coming super mini computer company that was trying to compete with DEC, which was trying to compete with IBM. Software Arts, we'll talk about, but they're most widely known for being the creators of VisiCalc, which you may or may not have heard of. Lotus, who was most famous for 123. Iris, I'll talk to you about in a minute, but that was a startup that I did, kind of a spin-out from Lotus, then Groove, my latest thing, and then kind of where I am. So where it starts is probably, what was this, maybe 74, I believe, at University of Illinois. This is the I've got a bunch of pictures, and I'm just going to use them as eye candy to help me through the story. But this was the Department of the kind of newly christened Department of Computer Science. I guess it had been going for a few years. I started, I think, the second year that they had a computer science major in engineering, and there were the kind what it was like to be an undergrad in computer science at that point in time was, as we were just Ed and I were just talking about, it was Model 29 key punches, submitting card decks to IBM 360s, doing machine problems, getting, going out and getting pizza, coming back, collecting your listing out of a box, after it had been processed. And I at the time I was, kind of struggling to get through school. I think the tuition at the time was $275 a semester. Room and board was a little bit more expensive. And I was a programmer at Department of Nuclear Engineering. Used this thing called Lockheed Sioux, which was a mini computer at the time. But directly across the street from Department of Computer Science was this building, this really strange-looking building with a tower next to it. And this thing, I don't know if you guys can see that. Yeah, a little dark. But this thing was called the Computer-Based Education Research Lab. And it had nothing to do with the Department of Computer Science. But every time I walked by this building, I would see people sitting at these terminals that looked like this, these big, clunky, boxy terminals with this orange glow coming out of the screens. And remember, this is an era where I'm using punch cards to submit decks to the computer. Yet these people are sitting in front of these graphics terminals. And I had seen storage terminals back in my computer science stuff, they look like big oscilloscopes that retained images on them. But this thing, when I kind of peered over people's shoulders, they were doing some amazing stuff. And it was, as I'll explain further, this system, these were terminals connected to a centralized system called Plato. And that's an acronym for Programmed Logic for Automated Teaching Operations. And these
stretch.
Yeah, well, you know how it is. You reverse engineer an acronym out of it. And in essence, what kids were doing was what students were doing.
Sorry, can you go back one slide?
Sure.
So is that the back end of terminals facing the other terminal?
Yeah, this is the back side of the terminal, and what you're not experiencing here, and I'll show you why in a minute, was these labs that these things were in. There were several of them on campus, but when you walked in, there was this background noise, and later on, and I'll explain to you why, it's compressed air. These things took power and they took compressed air, and you wonder why, but you'll see in a second. But yeah, there were these big monster terminals, and I'll talk to you more about that in a sec. What you would see on the screen is something like this. This was a fairly classic lesson on Plato that they used for teaching, and this thing was a fruit fly lesson, and you would learn about genetics basically by essentially playing a little game and learning how things combine, and essentially, I don't know if you can see this little arrow here is a prompt, and somebody is saying yes, female parent, and whatever, and you can see you can probably imagine it was a fairly compelling thing at the time, especially for people who used punch cards. This guy was the guy who invented Plato. His name is Don Bitzer. And he was a creative eccentric who really believed that computers might be able to be used as a way of assisting the teaching process. He was not a computer scientist. He was an educator. And this was Plato 1. It was in '68. And this thing here, this was probably, I don't know what computer this was connected to, probably a Burroughs or something. But he experimented in a very controlled way, did research on what would it be like to create lessons, and what would the structure of those lessons be, and what kinds of impact could it potentially have. He experimented with different kinds of keyboards at the time. You can just imagine the computational horsepower that was necessary to put up that one screen right there. But eventually he decided he wanted to get a grant, and he got a grant to try to build this system, and he knew he needed to build a terminal to do this, a graphics terminal. But graphics terminals were way expensive at the time, and what was really prohibitive was memory to back up the display, the persistent display. Sorry, this has nothing to do with collaboration, but you might enjoy it. It's amusing. So he and three other guys went and decided that they needed to create a display that had memory built into it because of the physics of the display. So he invented this little thing, and that's called the plasma panel. It's the plasma panel behind the TVs that you use in your homes. And this is the first plasma panel of, what is that? How many pixels? 64 by 64 or something? 16 by 16? 16 by 16. It's got U of I in there. But he invented it specifically so that to build this terminal, and you would drive it in such a way that it would, you'd turn on the pixel and it would just stay there. You could actually read it back if you really wanted to, but this was a really big deal. And after a few years, they fabricated, an actual, decent-sized plasma panel, and this is the one that ended up going into production as a 512 by 512 plasma panel. Around that plasma panel, he basically invented this thing called a touch screen. And It was essentially a row of LEDs and detectors, and that could detect with a fairly coarse grain where your finger was. You couldn't draw on it, but you could point at something in a fairly crude way. And then, kind of built up a terminal out of it. And the reason these terminals are so boxy is because, in essence, what he wanted to have was a multimedia terminal. And the kind of graphics he can do with 512 by 512 wasn't enough for him, so he put a microfiche projector in. And essentially, what you're going to see in a minute is that there is this random access, a light source that would project through the microfiche onto the ground glass on the back of the plasma panel, and essentially the software could select a slide to project on the back, and then the graphics could overlay on top of it. So this is done at one of the early terminals, and this is more or less a complete terminal. I've got this terminal at home. Actually, it's kind of fun. So this is a typical student, and Plato was initially deployed to junior high school students, to grammar school students. Then it went down to kindergarten, then junior high, then high school, then university, just trying different types of lessons. You see the headphones that the kid that he has on. Well, here he's putting in a microfiche that goes along with a student lesson. This thing right here is a disc, a magnetic disc. It is a big floppy without the carrier that went along with that lesson, and there were synchronized audio and fiche, pictures that went along. And I'm sorry, the compressed air was there to drive the microfiche. It had to be under compressed air, so you'd hear this steady hum of the air pump in the background in every one of these labs. And then when somebody would switch slides in the lesson, it would go ka-chunk, ka-chunk, and then the slide would select, and the audio was synchronized, and so on. So anyway, that paneling, I love that paneling.
So can I make a couple of quick
Yeah,
comments?
sure.
This is just context, and it has nothing to do with collaboration. Well, one is computer graphics in the 60s and 70s was largely completely non-interactive.
Yeah.
Okay, so people who did interactive graphics would say they did interactive graphics, so like plotting things on CalComp plotters.
Right.
So that's how revolutionary this was. Setting aside all the education stuff, the idea was you were going to interact with the graphics.
That's right.
The other thing is something Butler Lampson, I think, originally was talking, this is back to the memory cost thing, is that what caused Chuck Thacker to finally build the Alto was he just had a graph of memory prices, okay? And he knew there was going to be a point in time when the memory needed to back the bitmap display would be less than half the cost of the overall terminal.
Right.
And a year ahead of that, he started designing.
Yep.
Okay, but that's the
That's
memory
great.
plan.
Memory was it was a very big deal.
Right.
Very, very big
And
deal.
you don't even think about it now, right? I mean, I remember this is much later than that, but in like 1980 here, we hornswoggled DEC into giving us a special deal on an additional 512K of memory for that VAX downstairs, and it was $35,000
Yeah,
for
there you go.
512K.
Right.
And the final thing is, back then, everybody was using mainframes as PCs, which is sort of what this was. I mean, it was time sharing, but roughly enormous amounts of computing power.
That's right.
And one of the problems with mobile computing, okay, so for decades, we could use money as a time machine to bring us to where we'd be 10 years and therefore invent the software. And that's what he was doing.
Right.
You can't use money to buy you a mobile form factor and extra battery life without getting clunky and things
right.
like that. So in some sense, the reason that we have trouble dealing with envisioning the software for mobile devices and ubiquitous computing is there's no way to envision the future.
That's
You
right.
can't spend a ton of money to buy what you'll have in 10 years.
That's right. Yeah,
This
exactly.
is how we lived for decades by
Right,
wasting money
That's
to
right.
project forward.
That's right. And a lot of money it was. Just so that you understand the architecture of what you're looking at here, these terminals were connected. I mean, they were, in today's dollars, they'd probably be, I'm guessing, $10,000 to $12,000 easily per terminal. I mean, just because it's a limited run plasma panel. They got Owens, Illinois, to make these things. They got Magnavox to do the short run on these. these terminals. When I showed up when I started using it in '74, it was about 500 of these terminals, roughly 300 of them on campus, the rest of them in pockets of 4 terminals worldwide, at universities worldwide, from Moscow to Australia to here and there. All of them had dedicated communication lines. Each terminal had a 1200 bit per second serial line going to it. The reason there was that tower next to the building was that was microwave to the phone company facility to get communications with the people, with these other places worldwide. God only knows what those tie lines, cost. The terminals were connected to a centralized mainframe, a CDC Cyber, a 6500, which was a dual processor. I'm not sure how many of you are familiar with these ancient architectures, but 2 processors, 128K 60-bit words, 1's complement. We hadn't settled on 2's complement yet. We hadn't settled on 8-bit bytes yet. 10 PPUs, peripheral processors, which are I/O processors. And anyway, so it was a centralized time-sharing system with dedicated software for this system.
But the reason you could support 500s is these things were in many ways largely autonomous. The displays maintained themselves. There was the rear projection. So.
Yeah, it was sort of like this. You had the mainframe. We had a hardware group, and the hardware group was the group that did all of the terminal hardware and did all of the custom hardware that sat next to the mainframe. What there were banks of modems, in essence, and then multiplexers, so that eventually it could all channel down to one I/O channel that this peripheral processing unit could do. And essentially, this thing was sending out, I think it was 12-bit packets that are like characters to the terminal, and the terminal had memory in its screen. So every keystroke would go up, and every and that might result in a few some text coming down.
If I could interrupt real quick, from Microsoft, apparently they're going to be testing the fire alarm system tonight. Over here. So I'm going to turn our microphones off over here so that we don't interrupt.
Okay. If you have a question, just.
Sorry.
So by the time, as I said, by the time I got there, there were probably 300 terminals on campus. This is what the foreign language building looked like. Foreign language was. I would love to show you. I mean, this is an amazing piece of history. I think we're going to do something down at the Computer Museum this next year about it. But the amount of courseware was staggering, even at that point in time. These were one of the big things in the foreign language was English as a second language, and a lot of students went through lessons on these things. So I saw this thing. As a computer science student, I said, I want that. I want to work on that. It looked like a lot more fun than doing, compilers and things like that, submitting decks. So I went in and I begged and I begged and I begged and I begged, and I did everything that you would do to, if you wanted a job. As it turned out, that there was a project that the nascent hardware group was working on, and I had happened to have some experience because of my. I was a double E turned computer science person, and I had done some work with a 4040 and an 8080, and I had written some firmware and software for those things. So they were just experimenting with building this thing, which was the first programmable terminal. It had a Z80 in it, the very first Z80 that came out very early on. We knew a lot of people at Zilog, and this thing needed firmware to emulate what the TTL-based boards, the hardware, within the big terminal was doing. This one gave up on the projection, this particular model, but they were trying to do a low cost, a much low cost reduced terminal. So they hired me as a systems programmer. This was kind of the kind of a subset of the motley crew. There were about 15 of us, who were systems programmers. There's the cyber, in the background there. But it was fun times, and you'd do what you guys would do if you were systems programmers, the kind of gods on a system that had all these users. Every day, there was prime time and non-prime time. Prime time was when students were supposed to use the system. Non-prime time was when systems programmers got to take down the system, bring up test versions, and so on. And it was still very rude to crash it because there were hundreds and hundreds of users. But essentially, they told students, don't use it in non-prime time. It's test time. And so during that non-prime time, we wrote a lot of stuff, and there were essentially, as users of the terminals, there were two modes. There was student mode and author mode, and this is important to understand. Author mode was the mode that you would use the system in where you were programming the lessons, and it was mostly research assistants and people like that who were actually learning the language, and it was a scripting language that was called Tutor. That was more or less a very easy to use language for non-professionals to write these lessons in. And people did really funny stuff in it. We as systems programmers were writing in Compass, the assembly language, but the lesson writers were getting more and more and more creative, and they were the ones, the primary users during this non-prime time. They started writing some simple games. People would start to experiment, not just doing lessons on the system, trying to do interactive games. And as systems programmers, we put in a few very key primitives that let you have essentially shared memory between processes, between multiple users. So people started doing very, very simple games, a little Space War-like game, this one's a little maze game, and so on. One of the best early games was done by a guy by the name of Brand Fortner called Air Fight. He was a physics major, and he thought, my gosh, maybe this thing would let me model the physics of an actual aircraft. And so he did a really, really good rendering, first as a single user system, then immediately thereafter as a multi-user game where it had two airports, the circles and the triangles, and you would go into the game, and this thing here is the stick, and here are the pedals, and you would use this key and that key and push the pedal in and out, and you would take off, and you had to really learn. The different planes had different dynamics, and you would take off at an airport. It might interest you to know that is now known as Flight Simulator. The Bruce Artwick was on Plato, saw that, you experienced a lot, and there's the direct lineage to that program. It's basically the same thing. But many very advanced games, massive. Today we'd call it a massively multiplayer game, but I think we're talking about hundreds of users, not hundreds of concurrent users. Very intense gaming culture developed on the system. And there were
pseudonyms are pretty good too.
Oh yeah, we who were on this system, and there were tens of thousands of us. We were fortunate enough to have had an early peek at many of the things that we all take for granted right now on the internet. Online community being, the most significant one. People, met online, established relationships online.
Who was Pork Humper? Number 28.
I don't know.
Twinkle Toes, we got it all.
Suicide Jockey. Right. Well, actually, this is interesting because you can look at the group also and see this is more like the domain name.
Lots of alums.
Indiana University, New York. What is PFW? I forget. Purdue or no, something Fort Wayne, etc. You get the idea. But one of the most, finally getting into collaboration, one of the most well-used things that developed on the system was called Notes. And it was referred to as Notes, but there were really two varieties of it that were connected, one called General Notes and one called Personal Notes. Personal Notes is email. General Notes were online discussions. And, this is an example of, the popular files at CERL, the Computer-Based Education Research Lab. So, interpersonal relationships was number one, philosophy and religion, current events. Public notes was more or less the general announcements, sex, jobs, things like that. So actually, this is a little late. This is 78 to 92, so this is not from that era, but you get the idea. And in addition to notes, there was this thing called this is actually what the detail level of a given public note would be, and there were also two things, one called Term Talk and one called Talk-O-Matic. Term Talk was this thing. There was a button, a key called Term, and the concept, Don Bitzer's concept was, if you ever got confused in a lesson about a term that you saw, you could always hit the Term key. A little prompt would come up, no matter what you were doing. Down here, it would erase what was there, put this thing, what term, and you'd type in the term that you didn't understand, and it would give a definition. But we enhanced it to do other functions, and there were special system terms. One of them was talk, and essentially it was IM. It would erase the bottom two lines, and you could type to another user. You'd type in their name, and if they were online, you'd just start typing to one another. And there was this other thing called Talk-O-Matic, which was online forums. Just a little aside, one of the, as a systems programmer, I worked on projects with other people, and one of the projects that I worked on, there was this guy my boss told me he was the project leader of this thing, and I should communicate with him, contact him through notes, and find out what he wanted me to do. It was this logo interpreter. So I worked probably, weeks and weeks. It was probably about 6 or 8 weeks on this project with him. Never met him face to face. I communicated with him through through email, through these notes. Very eloquent guy. I used this IM thing with him, and he was just an incredibly slow typist. It was just very frustrating. This term talk thing showed you character by character as you were typing. Really, really, really slow. Very frustrating. But he was spoke very eloquently. When the project was over, I met him. I ended up going to his home for this party. There were about a dozen people who were involved in this project. And the reason why he was such a slow typist was he was a quadriplegic. And I had no idea. He was typing with a stick. And that was kind of a defining moment for me, if there ever was one. It really caused me to reflect because of the fact that I had been talking mind to mind with this guy, and it just leaves it left such an impact on me that in essence the computer was really doing better probably for me in that project in terms of working with that person than had I done it face to face. A, because he couldn't do it face to face; he was not mobile enough to get over there. And B, I had prejudices about if you reflect upon it, I would have seen him and said, "How could this guy do this?" And he did. And so for years and years thereafter, this just kind of stuck with me, this notion of online community. My best friend met this girl in Denver. They were boyfriend and girlfriend. They would fly, back and forth to see one another, and all the things that you would, see in terms of online community now, except maybe the old gray-haired guys on MySpace. I don't think there's that. I don't think it went that far, but it really developed as a community. About that time, probably probably 78 or so, I was sitting in the machine room. Again, that's the console. By this time, we had two Cyber 175s. I had been sitting around there, and somebody had left a copy of this publication that you probably have never heard of, but it was pretty interesting. It's called Computer Lib and Dream Machines, and this wacko by the name of Ted Nelson wrote it. And it was a really interesting book. You can't see this. One side, that's the back cover, this is the front cover, and one was upside down from the other. So it was really two books. You'd read one way and flip it over. But essentially, this was just coming out of the 60s, and the Whole Earth catalog had been through several revs, and it was, the computer as a liberating tool, a tool that eventually will change the world, for all of us, as a communication device, as this device, as an entertainment device. And so that was the Dream Machines part of it. That was more the hardware side, and this was more the what could it do to society, kind of thing. And one of the things that was amazing to me was I found out that there were things going on all over the place, not just at Plato, but people were had been thinking since, the 60s about some of these concepts. And, I was introduced to the concepts of Ted Nelson, sorry, I guess I should say, if you don't know, he's the guy who invented hypertext. A lot of the concepts laid out in here, he basically laid out this vision of many people using terminals, with creating text, that would be interlinked at very fine grained. It's not today's web because they were bidirectional links. They were always bidirectional, references. You could always chase references back. But it was fascinating. But in that book, he referenced things that Doug Engelbart did. And this demo in ¡68, that if you haven't seen it on the web, you really, really ought to take a look. There's a video that you can watch where Doug really demoed pretty much everything that I've worked on since that point in time. He demoed essentially remote collaboration. You could draw on the screen together. You could pull down a window and see a video conference with the person that you were working with on the other side. It was just really ahead of its time. And his concept was using technology to augment human intellect. And also J.C.R. Licklider. Again, there's this one little paper you can download that you should read because it's just stunning. The paper is The Computer as a Communication Device. And, they were just sketches at the time, but he talked about it as a communication medium and what it might do. And this really turned me on. I mean, the more that I would think about it, and I mean, a number of us who were working on the system really started to say, wow, this thing that we're encountering on Plato, we're building it and we're living it in an applied sense, and other people are thinking about it from a research sense. Wow, if we could just get together and talk about this stuff, it would be really good.
Can I interrupt one more time? So I tried asking Wozniak this question. He didn't take the bait, but I had a bunch of friends from the late 60s who were undergrads with me. Bob Wallace is the best known one, who eventually was employee number 9 at Microsoft.
Mm-hmm.
And it's back to viewing the computer as an empowerment device
Mm-hmm.
and software as empowerment. So a whole bunch of stuff actually came out of that culture. And actually Markov is going to talk in the class
that's great.
after Thanksgiving about
That's
his
great.
sort of drugs book and things like that. But these people really did view computers as empowerment, and in many ways the idea of charging for software as opposed to freeware and then a fee for support and stuff like that was offensive to guys like Wallace, which caused him to leave Microsoft. But it was out of this notion that this was this empowering technology that was going to be liberating to people.
Yeah, well, it is hard to put yourself back there. I mean, there were the 60s, and then there was the war. I mean, and you felt there was the man, and you you just wanted to. The fact that you could touch this thing, you could program it, you could do things with it, you could talk with people, you could build things. It was it's a plastic medium. If you had a concept of doing something, you could build that thing with your friends without having to go get funny money from the computing office. We used, they would allocate computing time by giving you, funny money.
Right.
$4.76. This job costs 67 cents.
Now, totally off the subject, the way we used to get Van Damme's hypertext research done at Brown in the late 60s was third shift, right? But they charged for it, and we didn't have money to pay for it. So what we would do every morning around 6 a.m. is run a job that would crash the system, taking with it the whole night's accounting record.
Oh, that's great.
And the operator would let us do this. There was this woman, I still remember her 35 years later, named Grace, and she was the third shift operator, and she would let us crash the machine at 6:30 every morning. And the reason was we made her daughter the champion Girl Scout cookie sales girl in the state of Rhode Island. I gorging on Girl Scout cookies, and in return for that, Grace let us blow off the accounting records.
That's wonderful.
That's how we kept the program
That's
going.
wonderful. That's great. That's great. There's so many stories in there because people had to improvise if they wanted to. So before I left Plato, a handful of people who had been systems programmers for a while really were starting to think a little bit more abstractly about what was going on from a community perspective and from a cooperative work perspective. I don't think I had read the term computer-supported cooperative work at the time, but that was really the nature of what of the discussions, and what we were really kind of trying to ponder was what lies at the juncture of technology, organizations, and people. Meaning, you could do technology for people to help people communicate, and that's what we were doing on Plato. But the theory, when we were starting to read some of these other papers, were, wow, maybe people in organizations could use these things to start to do things like we did projects, programming projects with other people. Maybe there was a use for this kind of technology within, corporate America. But we were students. We didn't really understand corporate America anyway.
So one of the things that was really innovative about Plato was you built in this tutor kind of abstraction programming language, which gave people power to actually customize this environment.
Right.
So I worked on a system at New Jersey Tech years after Plato called EYES, which did, much of the same thing, and we had this extensible language that was available to the users as well.
Yeah.
I think one of the things that we found, and it sounds like what Plato found, is when people could customize their environment with these tools, there was a real sense of ownership.
Yep.
And that's what created this strong sense of user community.
Yep.
So here we are 25 years later, we have these disparate tools, people have email and wikis and blogs and all kinds of things, but there's still a very limited sense of kind of community. You can't customize those.
Would you just hold that, because there's going to be a point where I want to talk exactly about that. There are lessons learned in the Notes experience about what happened from when Notes came out until till what it was like after it had been embraced by enterprise, then grew. It's all related to exactly that topic. It's both the pliability of the medium and the self-empowerment being an important part of the whole thing. So, lessons learned in the Plato era. From my standpoint, I could just summarize it. As I had gone from being, when I was submitting decks to the 36075, I was thinking of it from a data processing perspective. We were learning computer science from an algorithms and data structures viewpoint. We were being told that the jobs that we were going to have when we graduated were going to be in scientific computing or data processing, but it was a view of computing's role as something other than what I saw, which was more or less power steering for human interaction. And that really left a mark on me. The other thing that I learned, which is unrelated to this, maybe, but impacted me, which was the fact that everybody who I had grown to have respect for on this project was somebody who I would call a creative eccentric. They weren't following the normal path. They stepped back and said, whoa, there's technology. Yeah, technology is boring. What can I use it for? Nobody's done this thing before. I'll take a risk. What the heck? What have I got to lose? You know, I might be embarrassed if it fails, but I'll try and I'll try and I'll try. And the guy Don Bitzer, who did the overall architecture of the system and the hardware, was a creative eccentric. This guy by the name of Paul Tenzar, who did the language interpreter, that environment, total creative eccentric. There were things in the language that have yet to be reproduced in languages to this day, and I don't get why. I really don't get why. That little arrow that I showed you, that I was pointing to, that was the prompt, the system prompt. Every prompt came with natural language processing. And when you wrote a lesson, one of the first things you did was to define the vocabulary that would be recognized at those prompts. And when you type things, there were all these libraries essentially that would do answer judging, that would help the lesson writer to understand the statistical probability that the answer that they typed was more or less the right answer for the thing that you were trying to do. These were all people just trying out different things, and so I kind of took away, hey, it's okay to think differently. You know, that's something that I'd like to do later on. So most of my friends at that point in time, University of Illinois, was a good place to be from. You either went east or west. You don't stick around there for a long time. And there was the Bay Area contingent, and there was the Boston area contingent. And I interviewed at places on both sides. About half my friends went to each. Most of them went to DEC on the East Coast because they were working on this thing that would eventually become the VAX, and it had this amazing instruction set and all this stuff, and it was a project everybody wanted to work on. So a lot of them went out there. I interviewed out there. I interviewed at DEC. Actually got rejected. But I got 4 acceptances at this other little company, Data General. And Data General was an upstart that was started by some DEC rebels who wanted to take down DEC. And DEC had this theory that mini computers could bring computing to departments and bring low-cost computing to enterprises as compared to IBM. Data General basically wanted to be the low-cost. They believed that they could build stuff that was technically just as good as the DEC stuff, maybe not as elegant, but did the job, and it could come in at a much lower price. And it was a fun place. One of the things that was really attractive about DEC to me, Data General, and this is an era, I don't know if any of you have heard of the Soul of the New Machine, but that was Data General was trying to build a machine that would kind of compete with the VAX. I wasn't in that group. There was another little group off to the side that I just thought was really interesting. I interviewed with this guy, and he had already hired one other guy, and I would be the third of a core group to write a new operating system. And they needed somebody who could do operating systems and firmware because there was a new hardware architecture they were doing. So I said, hey, this is cool. I was a systems person there. I kind of like this. So this guy was John Sachs. That's the only picture I could find of him. And this system, and this is relevant, it's not necessarily relevant to collaboration, but it's relevant to the story. The system was just as bizarre as Plato might have been in its own little way. It was a commercial system, meaning it was intended to go into business, but rather than being a system with terminals, we had this concept that there was this thing that we thought we invented it, called the local area network. And it was a token passing bus at the time, and in essence, it was intelligent workstations, Micronova-based intelligent workstations, diskless, that the main components were these workstations and a file server. with tape drives and stuff like that. And you could use the workstation as a print server. And I wrote the terminal operating system, John wrote the file server operating system, and the third guy wrote a bunch of utilities around it, and then another whole group started writing languages and tools. But the thing that was really neat about the system was I had never had any exposure to this notion that the terminal might actually be a computer. And it was just fun. It was really a lot of fun building in essence, a distributed system. There was no local file system. It was a remote file system. But it was enjoyable writing this small code, this code, and it got me into the notion of looking at what was happening with these microcomputers and microprocessors. While I was at Data General for about 3 years, and there were some lessons to be learned there. Number one was the fact that as I looked around at every project that was going on inside of Data General and my friends who were at DEC, I couldn't find a single project where they were using the computer as a communications device. People who had Plato background had re-implemented notes and term talk on the VAX. I had re-implemented notes and term talk and with another guy on that little system that I just showed you because we were trying to do it. But it was not on the radar screen. The purpose of that system was word processing. It was supposed to be going up against the Wang OIS, system. So, number one, people still didn't get it, and that was a little frustrating. The second thing is that was my first time working for a company, and all I could say is I really didn't like interacting with other people in the political environment that this company was. And there were lots of meetings and meetings and meetings, and the projects just seemed to be less...
Let's say you're going to do great in your new job.
Thanks. I really appreciate it. But the projects that we had worked at a distance with other people on, it's weird, they were almost more productive than the ones where we had to have a lot of face-to-face interaction. It was odd that inserting a constraint, which was this medium, actually forced you to be better verbally about what your intent was and things like that. There was less grandstanding, all these weird things. So, and then the third one was more or less a technology thing. The mega mainframes that I had dealt with in college certainly were going to mini, but that was where it was really going. It was the micro was. It just felt to me that something, I didn't know what, but something was going to happen.
Question.
Yep.
On your point about the communication, it strikes me that may be involved today, actually, in all the outsourcing that's going on.
Mm-hmm.
Because lots of companies have found how to have poor requirements, and you ask somebody overseas to build it, you get something back that doesn't do what you wanted.
Yep. Yep. There are companies who are still learning the lessons that that we were trying to do there, and we as an industry still have not learned a lot of these lessons. Certain industries have taken global sourcing for granted, and they just adapt their environments. Certain companies, Microsoft is one of them, are laggards in using global development. Microsoft has very successful projects in India and China, but culturally it's a campus-based culture. And it's certain leaders within the company who understand, wow, I can use these, resources in Boston, resources here, resources there. All the talent isn't necessarily just here. But, what happened on Plato was you didn't have the choice. The terminals were where they were, the people were where they were. And today in business, cost pressures are such that the people are just where they are, and so processes form around those constraints, and people use collaborative tools in order to just make it work at all. So after a few years, just before, kind of as the project I was working on was completed,
Sorry, can I ask a question?
Sure.
Back then, were you supporting something other than sort of completely synchronous communication and completely asynchronous communication? Is there some middle ground between, email and chat that was commonly used?
At Data General or DEC?
Actually, probably in Illinois is what I really mean.
Okay. At Illinois, everything that I used for text-based communication, the chat stuff was real time,
Expected to be synchronous.
and the other stuff was asynchronous, and the games were the richest form of collaboration, and that was synchronous.
Got it.
But there was no, it wasn't a PC model. There was no such thing as disconnected operation, if you know what I mean. It was only a fully connected. The terminals had to be plugged in,
Right,
even if it was
but what I
asynchronous
mean is there's,
communication.
the guys out to lunch or something like that.
Yeah.
I mean, there's,
Yeah, that there were facilities in the notes thing to indicate that you were out on vacation.
okay.
But that's probably about the extent of it. Yeah. So about that time, because I thought that micros might be a happening thing. There was one little company in Cambridge called Software Arts that was hiring. I think I was number 29, employee number 29, but it was a very family-ish kind of company run by these two guys, Dan Brooklyn and Bob Frankston. Dan Brooklyn invented the spreadsheet, and Software Arts was the developer in a developer-publisher relationship with another company called Personal Software that actually brought it to market. They did all the marketing and sales, and this was the kind of the engineering company. And it was a blast. It was they at the time they had done VisiCalc for the Apple II, and it basically made the Apple II. If you ask, Steve, it was why people bought the Apple II. That's it right there.
And what Woz said is that because he had put slots in the Apple II, you could put enough memory in it to run VisiCalc, and the Trash 80 didn't have much memory. So
Well, he might be trashing it, but the Trash 80.
there it is.
That was my first job, was to do the port of the thing to the Trash 80. He's right that the Apple II was by far more successful than the Trash 80, but you can't trash the Trash 80.
Excuse me.
It was really a cheaply built. It's probably one of the most cheaply built machines I've ever seen. This was, whereas the Apple II was this beautiful white metal, whatever, it was just high quality. They called it the Trash 80 because it was silver plastic. It was just, it had that junk feel, but it worked, and it was a. I won't go there, in terms of telling stories in this thing, but it was a very challenging environment because this was a hobbyist computer market, and there were so many different computers. And there they go. Should we leave? The job that a handful of us had was to port VisiCalc from machine to machine to machine to machine. Each one had its own, I/O architecture for the screen, different subroutine libraries for the floppy. There was no real OS to speak of. There was just a little monitor piece of code.
Are you writing that in assembler or?
Oh yeah. Yeah, the state of compilers at the time, even though there were compilers there, they were so easily an order of magnitude. You couldn't get code generated that was even remotely close, size-wise or perf-wise, to what you needed. Not at all. And you're not doing development on the machine. We're doing cross-development. We had this massive Prime Super Mini where we had all our compilers and tools and things like that. And you download it through binary, encoded over a terminal emulator in here, which would write it to a floppy. Then you'd reboot and then test it, and then go back to editing in Emacs on this on Prime. So
Question from Berkeley.
yep.
So the way Waz tells this is he was building this cool hobbyist computer because he enjoyed it basically, and after a while he decided he could sell small numbers of them, but it was still kind of a small business. And then he notices that VisiCalc has had this great idea that you can actually do business with this, and suddenly Apple becomes a real computer.
Yep.
Within VisiCalc, did you guys have a period of kicking yourselves that you had in fact had the great idea and Apple got most of the profits? I mean, how did that shake out and how did it happen?
Well, so first of all, it was a very, just to set the perspective, to call this an industry at the time is a real, I mean, there were probably, it was a fair kind of a thing, not even a conference. You'd have, everybody knew each other, and everyone was stumbling into it as a business. Dan Bricklin figured out that he wanted to do the spreadsheet thing while he was in business school. So he had a business mind and a business conceptualization. Frankson was at MIT. He was a hacker. He was just he just loved to code.
Still is.
And still is. By the time I got there, they were already past the stage. They were already into the stage of it being a business, meaning I wasn't there at a time when it was pure hobbyist or stumbling around. They were already, the money was flowing in faster than they could deal with it. It was easily the, let me see if I get this right. I believe that over the life of VisiCalc, they brought in about 200 million, which is staggering. I mean, just truly staggering. I think it was like, I think at the time I was in there, they were getting $10 million a year revenue, and just our unit, software arts, and the demand by PC manufacturers, microcomputer manufacturers, was so great that we were just scrambling to build the stuff and ship it. So I wish I were there, but I wasn't there at that point in time. This was the team, and that's me right there. This thing that says TK, that was the next project that we worked on. We decided at one point that it wasn't going to scale to port VisiCalc from machine to machine to machine. So my job and a couple other guys on this picture, our job was to build a set of a compiler and an IL, an interpreter, so that essentially we could just port the interpreter and then build multiple products on top of it, not just VisiCalc. So I was in charge of the interpreter and all that stuff. Other people started rewriting VisiCalc, and this TK thing was our next product that we were working on. At the time that I was there, I had my office in the basement of this building, and one day Bob Frankston. One day I'm sitting there, and in comes. This is a very bummy crowd. It's Cambridge. It's just it's a university environment, and in one day walked these two guys who are wearing suits with white shirts and ties, and they just looked so weird. And they were, Frankston was with them. They were poking around. They went into a closet. They were in this closet for a while. They came out, and then a few hours later, some construction guys came in, and they put chicken wire up on the ceiling of the closet.
So it's IBM or the IRS.
right, exactly. And then they left, and then some other guys came in. This is all in one day with a bunch of boxes, and then Bob went in there for hours and hours and hours and hours and hours. And then, it was probably, 11 p.m., and he comes out, and I'm like, what are you doing in there? He goes, come on in here. And on this table this like folding table, was a piece of plywood with a circuit board attached to it, a clear plastic keyboard, and a stack of ROM listings and a monitor. And he's like, "This is the IBM PC. This is what's going to be that." And so we started playing with it, and it wasn't the best technology that could have been done at the time. They chose a clunky processor as compared to what else was available at the time. But you could just tell that they were serious about it. And as we talked about it, we just felt this was going to be an inflection point. This was where PCs were going to finally take over from VT100s everywhere. Terminals on people's desktops. Yep.
What year is this?
This was 81, late 81, I believe, something like that. Yeah. And so a number of us just scrambled. Bob and I flew out to meet with Gary Kildall over at Digital Research over in Pacific Grove, near Carmel.
Kildall was an alum of ours, actually.
Really?
Yeah.
Went up to meet these guys, Gates and Ballmer, who had just acquired this OS that they, eventually called MS-DOS.
Tim was an
from
alum
Tim
of ours,
Patterson.
too.
Yep. And so we just, we started talking. We said, how are we going to make this thing a success? And what people seem to forget is that the day that the IBM PC was shipped, there were two OSs that were available, CPM86, which was Digital Research, and MS-DOS. And we, as Software Arts, kind of had to place a bet. Do we do it for that? We didn't have enough resources to port it to both. So that was it. And I and a couple other people ported the Z80 code. There was this one guy who just had a brilliant idea, and he did a cross-compiler that took Z80 macro assembler and did a code gen of 8080, and it needed hand fix-up, but it worked, well enough. And we shipped it. But at the time, it was intense for me because you have to understand that all this time I'm still thinking the things that I had in the previous slide, like where is the human interaction? Where is using computer as a communication device? And finally, I'm thinking if we took the IBM PC and the LAN kind of thing that I had done over at Data General, except Ethernet was now starting to take off a little bit, at least in the mini realm. Then that would be a great platform for finally doing this notes thing again. So I started writing up specs for this product that would eventually become Lotus Notes. This was 82. So the primary purpose will be to provide, microcomputers can be used to construct a truly paperless office. And a means by which geographically distinct individuals can communicate with one another. Fast and reliable communications, mail, conferencing, forms, scheduling, text database, text retrieval, import, export, blah, 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 blah. Public key encryption. I was really turned on by some stuff that I had read in communications, or IEEE computer. Anyway, it was just, I was so excited by this thing. And so I wrote up this spec. Buddy of mine, two friends of mine from Plato got together, and we said, yeah, let's start a company, let's do this. I went out to try to get venture capital for it and struck out. I just went from place to place to place, Greylock, TA Associates, this, that, and the other. I was, I don't know, 26 or something like that, but I had no business experience. They didn't know what the heck I was talking about. And so I struck out. And I was frustrated, but I was having fun over at Software Arts. Bob and Dan didn't care that I wrote this stuff off to the side, they knew. And so one day I get a call again, as I did every 6 months or so, from my buddy John Sachs from Data General, and the guy who had hired me there. And he said, hey, Ray, I met this guy, and we're going to start a company. And we're going to build spreadsheets. We're going to build the best spreadsheet that that could possibly be for the IBM PC. We're going to write it in hand-tuned assembler. We're going to do this and this. He talked about all these ideas that was going to make it an order of magnitude faster than VisiCalc. And I said, you're nuts. Number one, I'm bored of working on spreadsheets. I don't want to work on spreadsheets. I want to work on this notes thing. And number two, you're never going to get an order of magnitude faster. But they did. He had met this guy, Mitch Kapor, and so they started this company, Lotus. And they, by the second time John called, he had written the product and they had shipped it. It was, I think, 7 months or something like that from when they started until they shipped it. Might have been a little longer than that. But it was just taking off. They had their business plan had first-year revenues of $3 million, and they did 53. And that's real money, and particularly for a small company. And so John was, yeah.
And sorry, and was the secret sauce the spreadsheet, or was it the 2 and the 3?
The secret sauce was the combination of two things. It was the 1, 2, 3, by the way, is spreadsheet, graphics, and database.
Right.
And database meaning you can store records in rows in the spreadsheet. And graphics meant you can select and do a chart in the thing without saving it and then loading a new program to do the charts, which is what you had to do with VisiCalc. That was key thing number one was that combination. Key thing number two was the perf. The order of magnitude speed improvement was shocking. And if I load this, I could demo this for you. If you load 1, 2, 3 on an IBM PC, I've got 2 demos that I just think are just amazing. Loading 1, 2, 3 on an IBM PC today and put it next to any contemporary spreadsheet on a current PC, and 1, 2, 3 is faster. And do the same thing with Mac Paint on the first Mac. It's stunning how fast it is. There's no hard disk, so it just everything is in memory. It just goes. So anyway, it was great. So John was burnt out. He had just done this project. He was the only one programming the core code. There were like 8 programmers. The rest of them were doing print drivers and stuff. And he goes, I'm really burnt. We need a version 2. We've got all these competitors nipping at our heels. Just come in and talk to Mitch. No, I want to work on notes. Come in and talk to Mitch. So I went in and talked to Mitch. We did a handshake deal. And I would come and work and do one version of 1, 2, 3 for them. And the day that it shipped, he would help me figure out how to do what I really wanted to do. So I started there, and 9 months, almost to the day later, we shipped Symphony, 250,000 lines of assembler. It was great. I mean, we renamed it by the time it shipped because we ended up having to rev 1, 2, 3 because we broke macro compatibility and all this. Anyway, but I shipped it. Mitch kept his word, literally kept his word to the day that it shipped. He came down and said, "Okay, dust off your business plan, and we'll figure out how to get you funded." So I, revved it again, did some amazingly compelling screen mock-ups, in Emacs. It was just, it had split windows, panes. You would select a line and it would change down here. It was just incredible. Does this have a date? No, it doesn't. Oh well. Then a guy
speaking downtown tonight, by the way. Mitch is speaking downtown tonight.
That's great.
At Voyager Capital event.
That's funny. I'm having breakfast with him in the morning. Then we started working on during that time. We got some Macs because they were starting to work on 1, 2, 3 for the Mac. So I grabbed one and decided to try to do some graphical versions.
Lee Oswald, Alcatraz, California.
Yeah. Yeah. I don't know. It was fun. I mean, I have a whole palette of these snapshots. They're great. These concept diagrams. But eventually, I got it to the point where we came to a deal, And Lotus funded me, to do this project. 1.2 million bucks, initial funding. And so I called up my buddies from Plato, Tim Halverson and Len Kaywell, and said, I got the check, let's do it. And they're like, you really got the check? And so they both quit DEC. They were still at DEC. And so we started this company, Iris. Now, Iris was a separate company from Lotus. We had a publisher, kind of like the Software Arts personal software thing. We were the engineering firm. They were the publisher. And we started working on it. And before long, I think this was in, 85, we had code operating. And I don't know if any of you have seen Notes, but it actually looks a lot like this, except a little less bright colors. This was a pre-Windows 1 version of Windows. Just random tidbits, but when the first couple months that after we had started the project, we decided that this graphical user interface thing might actually catch on. It hadn't yet on the PC. So we went to Digital Research that had a thing called GEM, Graphical Environment Manager, Visicorp, who had Vision, which was another one, and Microsoft that had this little thing that they had just hacked together called Windows. And it was just a few people, and it was the least mature of any of them. But I knew Bill by that point in time, and I had dinner with them, and they basically said, we'll do anything to get you as an ISV. I don't know what you're working on, but we're going to succeed. We're going to succeed. And he was very passionate about it. And
sorry, what was the installed base of Macs this is middle 86?
No, this is when we started. When we had to make that decision, it was 84, December 84.
Zero was the answer.
Zero, yeah. So, but we had to make a decision, and so the deal, basically, I said, Bill, if we can have the source code to Windows, if we can work on Windows with you to get it debugged while you're building it, we'll do the app for it. So we had this funky source relationship for many years where we just debugged along with the systems group, and there were two other apps that were basically doing the same thing at the time, Excel and Micrographics, I think was the name of the company that was doing a graphics package. They didn't have the source, but they were working in that era. But anyway, so this was what Windows 1 eventually did look like. It didn't have overlapping windows. It had tiled windows, but we believed in overlapping windows, so we wrote an overlapping window manager within the tile, as you can see, and tried to emulate a lot of the Mac-like look and feel because we liked it and stuff like that. But anyway, so we started working on it. Several years went by, and Lotus started to, by 86, when you can actually see this, we were communicating with people who were at Lotus through our VAX mail gateway. They decided to try to figure out how to market this thing. And so they started going to their corporate customers, talking about collaboration, talking about these concepts that we were espousing about using technology to communicate. People were not on email, at the time. They didn't have LANs. There were limited numbers of terminals in places. Some people had PCs for spreadsheets, but definitely, if there were networks, it was probably because of file sharing. Some early Novell, file sharing or sharing the laser writer, the expensive printer that somebody had bought, and the language that we were using to talk about the value proposition of the product just didn't resonate at all. It was just DOA. And so time just went on, and they just kept trying to do it. And I won't go into it, but the nature of the contract, our contract with Lotus, incented them to want to keep. It was better for them to keep it alive than to kill it. Let's say it that way, financially and strategically. So they just kept funding it, even after we ran through that initial funding. But after about 4 years,
this was Lotus money and not Mitch money, is that right?
Lotus money, yeah, Lotus money. And so finally, this one guy decided he knew how to sell it, and a lot of kind of the stars aligned, because this essentially what we had entered was an era of re-engineering the corporation, and this was a big, business in trends. You can always measure the trends based on the business books that sell at the time, but this book, which everyone was kind of shopping around within their corporations, was a manifesto that basically said if you can use information. It said many things, but you can use information technologies to revisit the processes within your businesses to eliminate boundaries, flatten the organization, get people talking with one another within the organization, and you'll be more profitable. You'll have a better, a better organization. So we hooked onto that from a pitch perspective, and started to talk up how we were good to as an enabling technology for this, this kind of revolution. And so it was enough to get the product out to market. We had a key customer, Price Waterhouse, who bought 10,000 copies the day one, made a lot of noise about it. They didn't install that many right away, but it was a commitment. We shipped V1 of Notes. It went to more customers. It was an odd technology product for people. Yep.
Go back a slide. So that message that says we'll be able to send mail directly to MCI from Notes. So what was actually the gateway situation at this point for that sort of stuff?
Yeah, the Notes, mail in general was not embraced by enterprises. It was a university thing and military thing. And MCI, CompuServe, there were a few online service providers, The Source, The Well, Echo in New York City, that used various technologies.
It was friends and family. They didn't interoperate.
They did not interoperate, no way. Eventually they interoperated through UUNet, but in the beginning they did not do it. MCI wanted to get their mail into corporations, and so we did a deal with them because they saw us as potentially making them relevant within enterprises. So we built a Notes to MCI mail gateway that ran on the Notes server, and just like we had written a VAX gateway for our internal VAX email system.
But the original design was that there was a Notes mail server for the people in that corporation.
The original design was very much like, it was modeled after Usenet. It was modeled as a departmental server, a small server that could serve a handful of people on a local area network segment, and then that server, as client server within there. There was a Notes client, and it communicated with the Notes server where the databases were, and there was that Notes server would communicate via an async protocol called x.pc to other Notes servers in a masterless mesh kind of fashion, kind of like UCP.
Yep.
And Notes databases are the fundamental unit of collaboration there. Mail is just an application. It's a forms-based application environment, and mail is just an application, of these, of this form type stuff. So, Notes v1, we shipped it. Notes v2, we added a lot more mobility support, client-side replication.
Why were the corporations so unwilling to do mail? Universities and sounds like the military have been doing it for a long time, and they just.
Well, let's start with the basics. If you have a company, let's say Merrill Lynch, let's say you're in New York, I don't know, pick a number of employees, or General Motors at the time, 60,000 employees. Probably hundreds of them had PCs. The rest of them, people didn't have terminals on their desks. We get so used to the fact, imagine going to work and actually having paper and a phone. It's hard to imagine, but that was the world, And so people were getting more and more PCs, but they were using them for spreadsheet purposes, for writing documents, or and things like that. But LAN-based email hadn't even taken off yet, at that point in time, within the corporation. So they just didn't see the value. Well, I remember Richard Eckel is over here. He was at Lotus in those days, and I remember seeing a study, and I can tell you who did that study, but that the email market, the annual email market by, it doesn't matter what year, was going to be $5 million. You know, there was just a trivial market. We shouldn't even bother with email. We should focus on the business solution aspects of notes. You know, it wasn't conventional wisdom that everyone was going to be on email in corporations. I don't know, do you remember what year finally, I guess it was when we acquired CC Mail that mail was really taking off.
That's right.
So that was what,
CC Mail would have been 91.
Yeah, 91, right. And even then, it was land-based email. It was, you know, put email in for your department.
Right.
Then connect them. Eventually, it would grow up into the company doing it, and then it got very frustrating. But even intercompany, forget about it. The internet was not allowed for commercial use at that point in time. So, you know, you had to beg, borrow, and steal to figure out how to just get a news feed, get hooked into a news feed if that was interesting to your.
So
people in the company.
Unix had store and forward email based on fixed routing tables and telephone dial-up numbers. Okay?
Right.
I remember, like, at one point I was writing a book in the early 80s with some guys at Toronto, and so we set up to call Toronto, and pretty soon we were carrying from UW all the traffic between the US and Canada was going over our stupid phone line because somebody discovered that we were calling Toronto twice a day to exchange chapters of a book.
Right.
And, you know, into the 90s, all of the email services were basically big time-sharing machines in Virginia. And you would have an 800 number, and you dial the time-sharing machine in Virginia. You could exchange mail with only other people with accounts on that time-sharing system. And it was sometime in the very late 80s that BitSurf got DARPA to agree to let ARPANET interchange mail with MCI at the time. That was the first time there was any sort of gateway between mail services.
Yeah.
It
wasn't until early 90s that finally businesses actually saw the prospect of value in having people communicate online, and even then it initially came in with specific, like the engineers will talk, you know, not necessarily the why would salespeople need it, you know, and it came in, you know, section by section within companies, and it was a fairly intense capital cost too, because just the concept of buying everybody a PC was serious money. I mean, these are somewhere between probably $3,000 at the low end, probably more like $10,000. You know, realistically per PC. Then there's network cabling. In New York, the reason I had brought up Merrill is one of our biggest obstacles in getting notes into companies in New York and Chicago, but mainly New York, was unions. They wouldn't. It was immensely difficult to get a wire pulled from one office to the next because the unions they just controlled that, and you just couldn't do it at all. So it was just a different world. But once people started connecting with email, they began to, you know, and they'd read the books, you know, the business books that talked about how how the technology could augment business process. You know, things started to happen. By Notes v3, v3, as in any major app, was the killer version. You know, the early the first one was the bleeding edge adopters. The second one, you had more tire kickers and you know, more visionaries. But then by the V3, V3 was the first time the product really showed through all of the original concepts that were intended, you know, at the beginning, and it had decent performance and so on. So that kind of started to take off. The other thing related to Notes rolling out was the fact that by V3, we started to have business partners. And to the point earlier, Notes had a very rudimentary script function-based and kind of scripting, and a relatively easy scripting environment, and it was built using templates. And so the mail app and the discussion app and things like that were just templates. Well, VARs were beginning to pop up, value-added resellers who would have domain expertise in a certain area, like a legal VAR or a sales management VAR, who understood what salespeople might use a technology like this for. So they brought their domain expertise in. They started creating applications and acting as reselling middlemen for the product. Lotus still didn't have a clue how to sell it. We could barely describe what the heck the product was used for. But these VARs understood how to communicate the value to a customer in the terms that were relative to that specific business process. And that is a huge lesson learned that you'll see later on, which is kind of abstractly the value of collaboration software and technology rises in some proportion to the domain specificity and the pliability of the tool to allow domain experts to customize it to their specific needs. It's not, some of it, and I'll get into this later, is a feeling of ownership, but some of it is very rapidly, I'm using an app, but the way that I use it needs this other client field in it. And if I have to wait and ask somebody else to do it down the road, it's not as effective as if I can just dive in, add the field myself, and it's done. The feeling of gratification of actually making the thing solve your problem brought that personal empowerment, that computer lib, to the individual who's actually got the problem that they need solving. Yep.
So a couple dates. ARPANET became NSFNet in 1988. So at that point, there were regional networks and corporations could hook up.
Mm-hmm.
The MCI mail interconnection was in 1989.
Okay.
So until then, closed networks.
Right.
And I know that as of at least a year after Microsoft Research was founded, so that is 1992, Microsoft still wasn't on the internet, and we provided a UUCP gateway for them, and they were a legally advanced corporation. So Microsoft didn't get the internet as recently as 92, even for there was like no connection.
Well, no, our iris.com, I think, was 86, and that was UUNet. But we released in 89, and again, nobody really wanted to. We didn't actually have a Usenet gateway, an official Usenet gateway that we sold as a product probably until V3 of Notes. So anyway, it was really V3 of Notes where it really started to be used productively by business. People started telling stories. By V4 of Notes was really the killer version. Even though V3 fulfilled what it was intended to do from a collaboration perspective, V4 of Notes happened concurrent with Microsoft releasing Exchange. And suddenly, when Microsoft released Exchange and we had mail and notes, suddenly a bunch of companies decided, okay, I guess now is the time to buy email. And it caused a huge wave in the Global 2000 worldwide to buy email. And notes went in that time frame from, I think, 2 million seats, 2.2 million or something like that, to about 60 million, 50 million or something like that.
So were there alternative corporate email systems prior to that?
The choices that you had at the time were departmental, buy a Super Mini, buy a VAX and run all-in-one, or Data General, get CEO, get Profs from IBM, or put in a LAN and get CC-mail. There were CC-mail competitors, but CC-mail really owned the market. We bought CC-mail with the illusion that we would convert those customers over to Notes, and some we did and some we didn't, as Lotus. But in any case, that mail drove the adoption of Notes, and then people started to use it for its collaborative features after they had bought the product. So it kind of inverted the sales model of the product. So,
but here's this is again back to a question somebody asked a minute ago. I mean there was a well-established sort of Unix-based national email system that a corporation could have used internally if they wanted to.
Yes.
Dating back to 1980 something or something like that. So
right, but with what friendly user interface? With that, there were tons of user interface, but it wasn't really packaged for corporate PC use. That's why CC Mail took off. They nailed the user interface in a way. It was kind of the Lotus 1-2-3 of email. It was so fast and so succinct in terms of how it delivered that experience that it was just what people wanted. Notes was kind of trashed at the time as being too slow. Why would you get something that overboard with databases and all that stuff when all you need is email? Eventually, we within the industry knew that eventually client-server architectures and things like that would be the right architectures. CC Mail was based on an architecture where there's shared files. Any user could write a program that trashed the mail database that everyone was sharing, and that's how how it was.
But I think you sort of went by it real quickly, but I think the important point there was you said on PC. At that time, late 80s and early 90s, technical users did communicate via Unix mail, and that's what we were perfectly happy with. Elm.
Yeah. I'm talking from the perspective of high volume
but it wasn't on
corporate
PC,
business.
so.
Yeah.
So
they were
sorry,
using Sun workstations and Apollo. They were using workstations or terminals on systems, not PCs. Yeah.
So CC Mail was a combination of a reasonable UI and a server side that was snappy. Is that right? Efficient. It was both those things.
Yeah. Users didn't know that there is a server. They just ran it on their PC, which happened to be connected to a LAN.
But the UI was good, and the responsiveness.
That's right. Yeah. There are lessons to be learned over and over and over in the industry that a key aspect of a killer app is high performance. Yeah. It's necessary but not sufficient. But in any case, so by the time V3, V4 of Notes happened, we had a lot of data in terms of what worked and what didn't work from a collaboration standpoint within major corporations. And I had lots of time over that period of time to understand academically more what the theory of business process was underlying some of the successes and some of the failures. So I'm going to go a little bit abstract for just one moment. One of the fundamental blockers in the sales of the product was, can you quantify the benefits of this stuff in a way that's meaningful to me? And we tried all sorts of ways. And this didn't work either, by the way. It was very obscure. But if you take this and abstract it, a salesperson could make an appropriate pitch. And what this really says is, if you've got a work process that involves a number of cooperating entities, you can go back to Ron Coase, in the 30s, who wrote about, transaction cost economics. And it's all, what is the right organizational form for getting cooperating entities to deliver a given product? And so we basically said, okay, this is the return on your investment in a collaborative technology is approximated by some overhead that you need to set up the connection first between the departments or between people. How are you going to actually decide to communicate with one another? That's a one-time kind of overhead. Then, for any given work process, how many times does it go back and forth to make the decisions necessary to deliver that piece of code, that iPod, that PC, that whatever product you're working on. How many cooperating parties are there? What is the cost of each iteration in terms of real time, the distortion, the mistakes that happen for every time you communicate back and forth, and you get there's a language issue, there's a terminology issue, there's hidden agendas. There are all sorts of reasons why there's cost in real process. So we tried to reduce it, maybe not with this model, but abstractly, we tried to communicate what the value of collaboration software was in terms where people could say, if you invest money, you will get benefit. Okay? But it was still abstract. It just still felt very qualitative to people. And that was a very frustrating thing. They also kept asking, okay, you've got all this experience. What, of all those places where Notes is deployed, what are the characteristics, the key characteristics of things where it's really worked really, really well and where it's just failed, where people made a big investment and they got nothing out of it? And there were lots of those. There were lots of, and to this day, there were lots of people who essentially brought the technology in, deployed it, and it made no difference. And the reason, one of the biggest core reasons, is that people gravitate to technology as a panacea, as a silver bullet solution, sometimes to things where there are deeper problems. Let's say that you've got, I'll just make something up. Let's say that you're an airline company and you've got a plane that you committed to people, and you've got you're late. You might have wiring problems or something like that, and there are multiple people who have to coordinate between France and Germany and whatever to get this problem solved. So what they do is they go buy some technology and install it and say, well, now we have collaboration software, so it should all be just fine. But
the French still hate the Germans.
Right. There's a cultural issue that's fundamentally like a number of professional services firms installed it early on, and they had a culture that rewards people for withholding information. I'm the expert at something. Software is not going to fix that problem. Some people would install the software when they should be also changing a business process. And some people put the software in, implemented a business process at the same time, the business process failed, and then blamed the software. And that happened a lot. You brought a bunch of people together, you said, okay, we have a new way of engineering this thing, and here's some new technology that you're going to use to coordinate with it, and it doesn't work. And net, nobody can really point to why it didn't work. It might have been lack of training. It might have been, misset expectations, whatever. But
yeah. So related to this, there's a paper now 10 years ago by Solow, a Nobel Prize-winning economist, in which roughly what he said was information technology shows up everywhere except in the productivity statistics. So the question is, why had corporations spent the entire decade of the 90s spending on technology and you couldn't see that it had contributed a thing?
Yeah.
And the reasons you describe are really the reasons. It's that it's not just injecting the technology, it's adapting the business processes to exploit the technology, or it's fixing the fundamental things that were broken.
That's right.
Okay?
That's
so in some sense, it takes a decade for those investments to pay off.
Right.
And additionally, they were measuring some of the wrong things.
That's
but
right.
It's really interesting. By the late 90s, Alan Greenspan had figured out that there really were productivity gains. Partly there was a 10-year latency, and partly you had to measure them appropriately.
Right. It also took some amazing, notable successes to really wake up the public consciousness. When Walmart developed cross-docking and used technology and business process innovation at the same time, people went, wow, they couldn't have done that without the technology, but the technology was kind of useless without the business process, and it started clicking. So people, I think, more, started, using that pattern. One of the things, though, that we noticed that was a pretty repeatable pattern for success of notes was that, it's kind of stated right here as it really is. Anything where you've got people who already know how to work with one another. They've got a process that we're working on. I'll take software development. I already know how to do software development. I know the things that I need to do. I know who I need to call to get a problem answered. I know generally who knows what. I know the information that we need to share together. I know that we kind of in our own minds already know the protocol for whom does what and then who does that. If you take something that's already occurring and then you throw this in, it's an amplifier. Kind of going back to Doug Engelbart in terms of augmentation. It's a great augmentation tool. Very high success rate in terms of augmenting lightweight things that were grassroots. So in looking at this thing, think big stuff is hard. The lightweight stuff, it's really, kind of working more and more. And our thinking about this kind of got a little bit more mature. We started looking at different business processes that were happening on one side or the other, and started having a vocabulary of talking about things that were business processes versus business practices. And Esther Dyson was probably said this the best to me. She said, in the UK, Ray, there's this thing called work to rule. They don't strike. They work to rule. And what that means is they continue to do this, but they stop doing this. Anything that's not a codified process that the company tells you that you have to do, you just stop doing. You don't pick up the phone. You don't do this. You don't do that. You don't take advantage of knowledge of who's the expert at what. You just do what they tell you to do. And the whole place grinds to a halt. So these things, these kinds of processes really require a different approach to the problem and potentially the architecture of the collaboration software than the very dynamic, people-oriented things that need practices involve people versus systems. They're more spontaneous. They're cellular, meaning people get together in little groups, do something, and it's fractal. Maybe there's another group, this and that, and so on. And I started noticing something going on in a couple of customers that we had. Two notable examples at the time. At this point, you go, oh, well, duh. But Chrysler said, wow, we're going to take this notes technology, and we have all these suppliers. We're using it very effectively internally. We're going to try to get notes out into the suppliers and actually start collaborating with them. AIG said all of our insurance company, all of our outside counsel working on all these millions of lawsuits, we're going to require them to get notes and get it installed and get it up and running. And so, I started to think, wow, is this collaboration thing going to start happening outside the company in this era, in the era coming forward, like it did in the re-engineering the corporation era inside the company? Are we going to flatten the organizations, not just the organization? So these are the kinds of questions, that I was asking myself, and even in the government, of course now, with 9/11 and everything, everybody knows the communication problem. Right. So I was kind of pondering this in a big way. Oh, I guess I should say one more thing. Back again, something happened to notes over the period of time that, and this is very subtle, from when we brought it to market until this era, which was about 96, which when we brought notes out, it had this UCP-like model. It was very departmental. The people who used the applications got to modify it. It was very empowering, extremely empowering. As the product became more and more and more successful, and especially as it became email infrastructure, corporate IT decided that it wanted to centrally manage those servers. And it didn't want all these different applications, being done by these different departments with different schemas to their data. So they'll just lock it down. And they communicated to Lotus, to us at Lotus, well, we need these systems management features. We need these professional programming features because we want to integrate it with our back-end enterprise systems. And so what had started as a very dynamic grassroots system turned into centralized enterprise IT controlled professional development. And the individual end users' use of these things devolved to creating instances of applications with templates that had been pre-created by IT and so on. So Notes was finding its way from this, where we had success in early Notes, this way.
Got moved into the glass
It
house
got,
then.
that's right. That's right.
That's
So
sorry, so you used to sell to groups.
we would
sell
sell
to
to
companies.
the line of business.
Got it.
At the edge, the person who knew what business problem they had to solve, we would sell to them, and they would deploy a small set of it, or somebody, between this department and this other department that needed to work together. When email took off, it was the best of times and the worst of times. It was the best of times because sales skyrocketed. We were being sold as IT infrastructure. But it was the worst of times because it got locked down, and it changed the basic nature of what of what it was.
I mean, the sales model is interesting because that's been like Salesforce.com's big success. Ignoring the fact that they're an ASP, it's that five
That's right.
folks can sign up for Salesforce. And
That's
suddenly,
exactly right.
they're beating the pants off the guys in the next set
That's
of
right.
cubicles.
And you might be interested to know that Mark Benioff took me aside at one World Economic Forum, and he said, Ray, when I used to work at Oracle, Larry Ellison and I and so and so and so and so were very concerned about Notes. We thought the unstructured database that you had built was totally unprofessional, didn't look anything like relational databases, but really looked scary because people were solving problems with it, and we thought, wow, look at all this grassroots use, look at all these thousands of apps that people are doing, and look at the fact that once they've built the apps, they can't rip it out. You can't take it out of their hands. And this is true today. You can't get Notes out of organizations. Even after they've shifted mail to Exchange, it's very difficult to pull it out. So Benioff basically said, I'm going to create Salesforce.com as a service-based Notes. And if you look at the early Notes apps were Salesforce automation, what today we would call CRM applications.
Really? Okay.
That was a very, our early VAR, was it MFJ or something like that? Did this great CRM system in it. And it's great because in CRM you want to modify it to the way you sell and track leads and things like that. And now he's building
Knock it off, though. That's great.
Yeah, and well, he took the best of it and did a service-based, thing. So,
Totally good.
so in any case, in this era, I'm thinking about this dynamic thing about how. Whoop,
Just before you continue,
Sure.
I wanted to get your ideas on this. There's this concept now that email has effectively died because of lack of sender authentication and massive spam injections and so on. So I've got this running bet with people that we're moving towards more of a Notes kind of capability where you'll build up federations of groups that are allowed to actually have open communication. And then you'll have rule sets that'll bound kind of the intergroup communication with others. What do you think about this idea?
It's a tough question to answer because I think email has. It depends on what you mean by email has died. Email is the default communication medium of choice, and it will be, I think, for quite some time. But in certain generational things, people don't use it anymore, or never used it, or just use it for their communication with their teachers and stuff. But I buy what you're saying about people clustering into groups around what they're working on, but I don't think it'll happen through federated email. It'll happen through workspaces in a different medium. And that's a great segue into the fact that with Groove, the concept, with Notes, what the centralized concept was a Notes database. And the Notes database is a shared space. Just like this board is a shared space for this group, it's a shared virtual space where we assemble people, information, and tools to get something done. And it happens to be virtual. That is the core paradigm that is successful in Notes, in SharePoint, in Groove, in every major computer-supported collaborative work product, in collaborative design systems from any of the major vendors, Matrix, or it's all about creating a space around the thing that you're collaborating. And so I think whether it's web-based, whether it's peer-to-peer, whether it's this and that, I think workspace, I buy that concept, but I don't necessarily believe anymore that email is the place that will happen, because it's so heterogeneous right now that you can no longer change the standard to add this feature or that feature. It's just out there, too heterogeneous. So in this time frame, I'm thinking to myself, what kind of an environment technologically could I build to make it really easy for dynamic work groups to form across enterprise boundaries? The problems we had in Notes were that you needed a Notes server, and you needed to get the partner's IT organization to get a Notes server in, and if you had 200 companies that needed to work together, it could be impossible. The amount of time that it takes to coordinate getting everything done, doing cross-certification of all these different keys to make sure that federation, everybody securely federated, it was really, really bad. And what you really wanted to do was to enable people to do the same grassroots stuff that you could do within a group, within a department, but across firewall boundaries and across all the nastiness that is this nascent internet. So one day I'm sitting at home harassing my son, who was this big at the time, and he was into Quake. That was Quake, not Doom, right? Yeah. And I was just blown away. I just couldn't get him off of Quake, and I started talking to him. I mean, this is over many months, and as it turned out, Quake. He was playing Capture the Flag in Quake, and I knew there was no centralized. I was pretty familiar with interactive gaming from the Plato stuff, but I knew there was no centralized service he was using. The way that this was working was people were hosting the Quake server on a PC in their house, and were dynamically forming groups in more or less a peer fashion. And I was watching how he was coordinating with these other people to go capture the flag. They use this little voice add-in called Roger Wilco, and he'd say, "Hey, go hide it over here, and I'll come over there, and I'll do this and this." And if there was ever anything that was a dynamic, effective collaboration environment, this was it. This was absolutely it. And at the same time, my daughter was using AOL Instant Messenger, and I started to. That's a different subject. I'll just stay with the Quake thing right now. So I just basically started going, okay, what can I learn about this architecturally? Is there some way to bring architecture together in a peer way that wouldn't require IT to get involved to get these work groups, working with one another? So I did this Groove thing, and I'm sorry this isn't working right now in terms of.
This was Flash.
This was Flash before. But in a client-server environment, it's an RPC-based environment. But in Groove, essentially, it's a message queuing environment. The fundamental architecture is message queuing. So if I could get a change that you did within a collaborative workspace published out as a message in a message queue, and asynchronously somehow tunnel that message through firewalls, I could essentially get these. If I could get this multi-master sync problem, worked out, I could do a collaborative workspace without the notion of any server at all. And so this is essentially what we did. It took a lot of people. At some point, it would be anybody who's really interested, I would love to give you documents, because there are some people who are into computer-supported collaborative work who understand the novel nature of the technology and what was done. But in essence, it's a collaborative editing system with an application framework that lets you build arbitrary apps on it. But it's masterless and fully decentralized and fully asynchronous. You can pull things off the network, work offline, plug it back in. Everything resynchronizes. Guaranteed consistent state amongst all peers, and it just works. If you downloaded it today, everything is encrypted by default. There's no knobs to turn. Everything is encrypted to disk. Everything's encrypted on the wire. It has all sorts of different authentication models, from self-certified to organizational issued, PKI. It's a very robust model, and the paradigm is virtual office. That's essentially what we were trying to do. We were basically saying this is something that you can work with, that you can keep all sorts of stuff in various workspaces and work with other people virtually over the network.
So, comment on the program. I remember when you were doing this, telling me that it's much more common now for people to think in terms of event-based programming.
Mm-hmm.
But back when you were doing this, we thought of entry point, where, exit. And you were saying how hard it was to find people with the mindset to build this message queuing paradigm where you're hanging around waiting for events.
It's asynchronous totally from the ground up. Because we had a fresh code base, because it was brand new to the internet, we just basically said some very key tenets like no wait cursor. You design the entire product from the ground up so that everything internally is asynchronous, so that you have a very clean model view, controller type architecture. Everything is asynchronous both within and across computers, and it just feels good. When you use it, and so we started selling this thing. We achieved some level of success, and I'll just tell you another story just so you can see the nature of where it might be used. On March 15th, 2003, I get a call. I'm at my summer home up in New Hampshire, and I get a call from this Navy doctor who I had heard was using Groove within his own. He travels a lot, and he was coordinating a bunch of his team with Groove, and he was in Iraq, and or no, he wasn't in Iraq. He was in Kuwait, and he said, Ray, we'd met before. I'm sitting here with 30 different NGOs. And we know that this Thursday we're going to invade. It hasn't been announced yet, but we're going to invade Iraq. And my job and the job of these NGOs is to come in after the troops, hours after, and provide aid to assess the damage that's been done, figure out how many hospital beds are needed, how many units of plasma, the water situation, this, that, and the other, and to all come together as 30 multinational things and help people after we've gone and blown things up. And we have a little problem. We've been working for 3 months on a schema, and the schema is a paper form. And we finally reached agreement by forcing function, because this is going to happen, on the paper form. But nobody knows nobody's in agreement how to get the paper forms to the front line, from the front line. This is how it was done in the old days. In the old days, we had encrypted walkie-talkies. We would fill out the form. They're encrypted because they don't want to let either side know what the actual situation is. But we don't have encrypted radios that work across all the NGOs because of this, that, and the other. We're freaked out. The only thing we all have is we all have sat phones, and we can all get to the internet, and we all have laptops. So I was thinking we could take that paper form and transliterate it into a Groove form and just put Groove on everybody's laptop. What do you think? Can you help us do this? We have to have the forms done by tomorrow because people are deploying. They're forward deploying, to wherever they needed to go. So we built this form. That's the paper form that we transliterated. It was a rapid assessment form, and you circle this and you do this stuff. But we basically did it that Sunday. He took a USB key drive, and they went from each person who had a laptop, and they made sure that they did a test on the local LAN, in the tent, and then up to the satellite thing. Because of Groove's architecture, it works equally well on any bandwidth, from 9600 baud or 4800 baud satellite phone all the way up. So they just did it, and they brought together, just tons of people. I don't know if you can see this, but you can't read it, but there's just many different people and different organizations, and it worked. They went out, and it brought people together. Felt really good in the middle of this bad thing that's happening. That it worked, and suddenly the word started to get out within NGOs that this thing works. It's encrypted. Nobody can look at it, even if they have access to the satellites. And it takes 5 minutes to learn. I mean, literally, they were walking around with a USB memory stick, giving people 15 minutes of training and telling them what to do. They didn't have to understand the whole thing. They just did it. And it started to be used in many other things. One of the other, key things that it was used for, it was used for hundreds of different applications. One of the biggest challenges that was not written about much was that the green zone was relatively safe. This is in the weeks and months afterwards. The green zone was relatively safe, but they were trying to stand up ministries and an embassy and all these different things. And in order to communicate with the people in other embassies or in other parts of the government, you had to go outside the green zone and get in an armored thing and subject yourself to physical harm. Guess what? They just gave them all Groove, and they started actually using, technology to coordinate getting together. And we had a third party come in who had an Arabic chat translation tool. So in the Groove chat tool, that one would type something in and it would come out, in English, and then they'd type something back, and it was fairly impressive. That grew into lots of communication amongst NGOs and amongst the government and so on. And so eventually it ended up being used within the government in a number of different ways and so on. So all I can say is this never would have been able to be done in order to do this with web technologies or with client-server technologies, you would have had to throw the server in the back of the Jeep and go out there, and it just never would have happened. And one of the most fundamental things that the NGOs said was, we don't trust any organization to own the data. We all must have equal access to the data. It's a political thing. They're competing organizations. It's just a very odd situation. And the same is true in the government. The NSA, the FBI, the CIA, nobody wants to acknowledge that somebody else is hosting the data for them. They all want to be equal participants. And so centralized architectures don't work for certain organizational frameworks.
So now let me change the subject totally.
Yep.
Okay, Peter Newport is a friend of mine.
Yep.
And this is the guy at Microsoft who's in charge of figuring out what the sort of healthcare business model might be.
Mm-hmm.
And the big question is, who owns the electronic medical record?
Right.
And the only reasonable solution is the patient owns it, because there is no incentives for different hospitals to collaborate. Because I don't want to make it easy if I'm the big incumbent, if I'm UW Medical Center, I don't want to make it easy for my patients to walk over to Swedish.
Right.
Okay?
Right.
So, and in some sense, HIPAA says the patient owns their own medical record, but this isn't implemented. So this sounds like that story, right? In some funny way.
It is. It's difficult. It's not. It is in theory, but in practice, to actually do that, you need you need a standard that is much more.
You need a standard,
yeah.
but still it's a question of who owns the data.
I agree with that, yes. There are all these issues. So we learned many, many, many lessons from this experience, and I'm just going to give you a few. We didn't try to solve all collaboration problems known to man with Groove. We knew that there were big companies like Microsoft who had things like SharePoint that solved a broad variety of centralized collaboration things. We were very focused on the edge. And I'm just going to go through a couple of these. There are so many lessons that you learn. The DoD in particular was fascinated by the question of, does decentralized technology subvert command and control? And it's a really interesting topic in and of itself. And well, whatever. But in achieving value from this, I'll read this in case you can't see it, but in achieving value from this collaborative system, real-time shared activity awareness catalyzes swarming, yielding quantitative and qualitative benefits. So what I mean by that is Groove these are truly patterns that you can apply to other products. This is just stuff that we learned with Groove. Groove has this interesting user interface device that we didn't realize the power of it when we implemented it, and that is that we display the member list of a given workspace when you open it up, and it's just the members of that space. And we change the icon and the color and stuff based on whether you are right now whether that other person is working in that same space, and they have the window on their screen. We also have, we noticed immediately when that happened that the same thing began to happen online that happens in real life when you have an office that has a window next to it, meaning somebody walks by and they see that you're not busy, or that you're working on something, or that you're meeting with so-and-so, and you realize that you can reduce the coordination cost by just walking in and joining the conversation and talking to them, because you know contextually where their head is at that moment in time. So we noticed real-life swarming. We've talked about swarming, in CSCW for quite a while. It really happened. You'd notice that so-and-so is in the space, so-and-so is in the space, and what we did was we added audio alerts and pop-up alerts that are customizable on a per tool, per workspace basis, and per person. So I could say, if Richard Eckel comes into this space, make this noise. Or if somebody adds some new data to this space, make a noise. And what it does is it draws people together very, very, very effectively, and you reduce the coordination cost. That's real. This is a pattern that other UIs should take into account. This is the point that you were making earlier. Workspace customization drives value because of users' ability to rapidly shape their own working environment. And it's not in here. Maybe it's in another slide, but this concept of trust and ownership because they've shaped their environment is a very material thing. And organizations, you start with this, and then once you introduce this into organizations, they then achieve incremental value above it by connecting their back-end systems into it. A lot of those things that I showed you that happened in Iraq started very dynamically, and then the Red Cross, for example, would say, wait, we have a whole bunch of people back home who want to see what's going on in this space. So they would connect in through a connector, and suddenly the stuff that was in the space, a limited set of it, was republished into SharePoint, and a much larger group could see the activity that was going on out in the field. Elements of success, there has to be, in a high-stress environment, a visceral need to work together. Otherwise, it's a dead workspace. People don't go and work in something because somebody told them. The most successful workspaces are ones where people feel the compelling need to do. And by the way, that was a lesson learned also in in notes email, people, when you ask them if they collaborate in email, they always say no because they think that they're doing email for themselves. It's a personal tool. And the more you can make a collaboration tool feel like you're getting personal value out of it selfishly, then other people will get value out of it. Everybody makes a collectively selfish decision, and it ends up benefiting everyone. Oh, this is it, right here. Although participants in the workspace have a shared objective, individuals only participate if they selfishly find value in doing so. And trust yields participation because of safety, a feeling of safety, especially important across boundaries. When you're in an emergency management situation and you're needing to do work with somebody who you don't know if they're a bozo, you don't know if they're going to be disruptive, you want to make sure you only invite people to spaces that, or you get to know people and set up trust within that environment. So this is just like a little snapshot. There were just lots. All I can tell you is there's immense value in this edge-based stuff. Another lesson, which I'm not going to bother to write up here, but organizations have a really difficult time appreciating this. People do. People get it. But the only way organizations, even to this day, the only way that large organizations value this is when some high-profile person within the company tells some story and takes a personal risk and is a personal champion for edge-based tools. Organizations who do central procurement think about organizational value, and they really don't appreciate the edge value.
Did you have, is that like a terrible question, did you have sociologists working with you, or did sociologists study this, or does this just sort of become obvious even to geeks as they see how the technology is used?
We didn't have sociologists or anthropologists or anybody like that really doing it. There were some people at Harvard Business School and where was Wanda Orlikowski at MIT. There were some people in the computer-supported cooperative work realm and in the business school realm who have done studies of this, but not at the level of what, for example, people studying what's going on in MySpace or Friendster or things like that.
This predated interest by that community in what's happened.
Yes, it predated it, and it's also people. I can't tell you why people don't study collaboration within business more because of the value involved in collaboration in business. But I don't believe there is a huge. This kind of stuff is known by people at the fringe within the computer-supported cooperative work community, but not much beyond that.
Left field question from Berkeley.
Yep.
So this is all at the level of individual human beings, but the Homeland Security business has this notorious problem that the FBI and the CIA and 65,000 other partners fight over what they'll divulge and over formats and over everything else. Could something like this work at the level of organizations where there's suddenly an incentive to get your data contributed to the pot because maybe you'll be blamed or something if you don't? The way they try to solve this now is they're all having sit-down meetings to work out the rules in advance, and with 65,000 people, that seems hopeless. On the other hand, if there was a sense in which they viewed it in their selfish interest to show what they could contribute, maybe you could shift the dynamic. Does this work for organizations as well as people? I know.
My problem is I have real data on this one topic, and unfortunately it doesn't make me happy. Groove was sold into Department of Homeland Security. It was deployed to 20,000. It was deployed in an architecture that involved both centralized web publishing and decentralized kind of layers of workspaces, meaning a hierarchy, meaning the people at the top were at the core emergency management centers, and TTFs and people like that were in one set. Then a state would have, a set of things. Then the state would manage communication with local, and each one had shared members. And they tried to use the spaces as a mechanism of feeding information up and then publishing, out. It's very interesting, and government bureaucracy is just breathtaking. That's all I can say. I mean, the technology works and worked. The processes were sound, but the number of careers that were on the line, the number of people who find reasons not to work together with one another, resemble that thing that I was saying about the NGOs agreeing on a schema. If there's a dysfunctional bureaucracy, the technology isn't, at least in this case, even grassroots technology is not helping to solve it. I mean, one of my favorite examples is there were some terror suspects in Buffalo that maybe you read about. I think there were 8 guys who were in a little cell. And what happened was New York, Dallas, and FBI decided to use Groove as a trial to see whether they could share information in doing an investigation related to terror. And it worked. They found these guys really quickly. They went and this is all a story that's being related to me. I don't have personal knowledge of this because it was a classified environment. But I can't tell you exactly what they knew or when they knew it. But these people, within a very short amount of time, figured this out. The lawyers from the agencies heard about this, shut it down, just totally shut it down, said this will never happen again, because because they weren't consulted in the processes of whether they should have permission to exchange that information across those organization boundaries. And so then the lawyers between the agencies got Groove and started working with one another. There you go.
Question from UCSD.
Sorry?
A question is this academic, or do you draw a distinction between communication tools, collaboration tools, and cooperation tools?
I do, but it's just the choice of the tag that I put on it. When I talk about communication, I generally think of a channel, between two people, or I think of communication as something where the context of the interaction is in the minds of the people who are working together, not assisted substantively by the medium in which you're communicating. This is a gray, there's a gray area in between, but let's just start with that. When you get to effective tools for computer-supported cooperative work, it almost always involves some sort of a shared space, a shared view of something that you're using to maintain the context, to enhance the context about which you're conversing. So in a phone conversation, everything I'm talking to you about is the context is in our minds, and the communication channel is just carrying the signal between us. I just think collaboration technology is more oriented toward using the technology to enhance the context. I don't know if that helped. So Groove was bought by Microsoft. I have a lot of thoughts about where collaboration technology should go. Independent of my current role at Microsoft, when I came on board, I was like a kid in a candy store, because essentially I had been working on one domain, one type of collaboration modality in Groove that was very edge-focused, very peer-focused, but it's not the complete picture. You need other forms. In order to have an effective collaborative interaction, you need audio conferencing so that you can get nuances of whether somebody's angry or whether they're happy, or that modality is important. You need publishing types of modalities. There are just many different forms of technology that are useful in different ways when mixed together, when mashed up, to do different forms of interaction. And Microsoft has been investing significantly in this as a specific area of competence. Since that time, I've gotten much more into this services thing, and I won't really talk a whole lot about this, but it's very important in my mind. Right now, I think we're at a juncture in our industry. We've been, at least since I've been in the industry, there have been several major industry transitions based on the steady progress of technology. Microprocessors happened. I talked about that earlier. That was a big, I guess mainframes to minis to PCs, PCs to LANs. These are all major technology transitions that let us as architects thoughtfully consider what's the best architecture to accomplish a given solution with this new technology architecture. Right now, one of these is happening, and it's because of the confluence of factors about how computing power continues to increase. It's not so much on single processors at this point in time. It'll go to multi-core and many-core, but it continues in aggregate to increase. Memory keeps getting cheaper. Storage is just, it's just amazing to me that we're going to have terabyte hard disks, in our desktops, 100 gig, in our 200 gig in our laptops or camcorders. It's incredible. And in terms of communication cost, this has also happened, such that we don't even think about the cost of doing things with people across the country or across the world, whether it's voice or data. And all of this really enables us to reconsider what's the right architecture, what's the best architecture for delivering a solution that might have some rich component at the user interface and potentially some rich component up, in the cloud somewhere. And that is enabling us to consider, should we fundamentally build massive data centers as resources that are abstract resources up in the cloud, out on the internet, and thoughtfully architect different types of solution, rebalancing some functions up there, some functions on edge devices, and so on. And I think this is going to impact both consumer things as well as enterprise things. On the consumer side, as I said, media devices. And we've got this broad range of media devices now, from iPods and Zunes to little media center things, to media centers in our homes, to PCs, camcorders. Again, digital cameras. I'm sure everybody now uses digital cameras, and the architecture for presentation and sharing of that media is dramatically different depending on the collaboration, the sharing scenario, the consumption scenario that you want. For example, for produced media, like from Hollywood, the right quote-unquote architecture is to centrally maintain libraries, vast libraries of this media, and to cache it on devices. So if you lose the device, you just get another copy of the cache, another cache copy on another device, and so on. But for your own personal media, it's exactly the inverse. You take your pictures, you might load them onto your PC. Pictures are small enough where you could replicate them completely in the cloud. But home movies, I don't know if you've done it, but I have ripped every one of my videos now that goes all the way back to when my kids were, really small, and I have to have a 2.8 terabyte, server in my house. Now that's just going to be a couple of disks in a PC in a couple of years, but the upload bandwidth, but from my home up to the cloud is pretty slow still, and to dribble, all of that stuff up, it's going to take quite a while. So I believe, that the architecture for personal media may settle out as multiple PCs in a home replicating for reliability your personal media and sharing cached copies up into the service, where you share those cached copies out to other people. And so for every app that we do, I feel as though at this point in time we're at a juncture where all of the things that we're going to be doing for consumers and for businesses are going to somehow be composite applications between things on the client, things in the service, things on enterprise servers, and so on. In business, this has never been more relevant. To the point made earlier, most major enterprises now are doing collaborative design and different business processes all over the world. It's not just India and China. They're just different, areas that are clusters for different aspects of business, and we can use technology and architecture to design collaborative solutions for those specific things. If it's marketing people, it'll be marketing-related tools. If it's engineering and design, it'll be those forms of tools. And because we're now getting more mature in the use of these collaborative technologies, there are lots of different, almost semi-vertical styles of use of these collaborative technologies within different domains. So, I'm not sure how many of these things you guys are familiar with, but in terms of business intelligence, companies now want to not only look at the real-time status of their own systems and their own process, their own inventory. They want to reach out and through into partners worldwide. And this isn't just if you're a channel master like Walmart, where you're a big company with lots of people serving you. There are many, many, many situations where you have lots of little companies who are working together, who are codependent, who really need to understand the status of each other's systems. In the professional services space, the dream now of auditors is to actually instrument the companies that they're auditing, so that instead of doing a periodic review of the books, they're watching everything as it's happening and kind of acting as a real-time monitor of what's going on. And it's scary in some ways, but it's the natural progression of the kinds of things that are going on. And they could ask a question of somebody kind of in real time. Well, what do you mean about what does that mean?
So I have a kid. I won't explain the background to this, but he's currently running a Starbucks store in Washington D.C.
Really?
And Starbucks does that kind of stuff. I mean, they have instantaneous insight into what's going on. And if he's got somebody ripping him off, the people back in master control know this before he does.
Right.
It's quite remarkable.
Yeah, it's amazing. It's amazing. And I don't know where use of technology for business process ends and collaboration begins, because collaboration contextually is kind of woven into the workflow of these different things. But suffice it to say that I believe that these things are relevant more than ever, and we haven't even you could either view it as, well, now it's in the fabric of everything, so it's not worth talking about anymore, or, wow, we haven't even scratched the surface yet because there are all these new technologies coming out. Look at this, these conferencing systems that Cisco has. Look at the real-time stuff that Microsoft is doing. There are lots of new technology innovations that will let people take different, angles as to how people work together.
Let me ask about corporate collaboration, though. Does it tend to be peer-to-peer, or does there tend to be a hierarchy?
It depends on the industry and the sub-industry. There are clusters. If you just go to China in a given, Shenzhen or something like that, you'll see a group of manufacturers who have clustered together because they need to work with one another, and they might do a sub-assembly within a hierarchical process. So it's kind of both. Yeah. So that's really it. I don't. I've kind of been rambling for quite a while, but it's been a fun ride, and it's an area that interests me. quite a bit. So.
Just take a minute and see if
Yeah.
people down south have questions.
Absolutely.
Questions at San Diego? Got anything left down there?
I have a question. I've been wanting to ask this because we have wikis that we use for this class, and I wanted to get just your take on wikis, what you think they're maybe good for, and if you think that they're worth the hype.
Wow. Wikis are one of these things that, had you told me, based on my experience, past experiences, if you had told me you were going to take something that had read, write, editing ability and anonymous access and throw it up on the internet and have it actually be productive, I would have said you're nuts. But it's amazingly useful for certain things. I mean everybody will point to Wikipedia, but I really do believe that there are, when you have a set of information that needs to be structured, but people don't really know how to structure it a priori, it's a great work pad for people to go in and start juggling information and reorganizing it. I think it's I don't know about the total hype, because there are things like JotSpot that go from Wiki into forms-based application land, and then you're more in the Notes apps or SharePoint, and then you're down the slippery slope of all those things that I was saying in Notes about the corporation wanting to control the schema and so on. So, I believe in team sites. I believe in wikis. I don't know if I believe in I'm not yet sold on the mashup of those two.
So this isn't quite collaboration, but have you thought about the reason for the rise and fall of these sort of the various Friendster type sites? I have no idea what causes these things to be hot and then go cold. And
God, that's such a fun topic to talk about. Social networks in general are, I'll just start with some basic tenets that are useful tenets, I think. Number one, you can't have a social networking site, in my humble opinion. You can't create one unless you are a member of the community that you're building it for. So the reason Facebook is so successful is that it was built by, Mark as a college student, and he understands the things that I forget about the things that are meaningful and how people interact and what they're looking for on a daily basis, and how people are interested in what happened at the party that I missed, and they're just things that are very, you can tune the user experience directly for that thing, and I think that you could equally build a social community for high school sports. You could build one for parents of high school or soccer parents. You could build one for any community very effectively that is an identifiable community if you're one of the people in there. But in the realm of kids, I'll just tell you a story of what my daughter told me a few weeks ago on Parents' Weekend at UPenn. She's been a Facebook person for ages upon ages, and I'm also in Facebook, and I watch what goes on with, and all of her friends, and are friended me, and so I noticed that the nature of what is being done on there is a little bit less risque now than it was a year ago or 9 months ago. And I said, "What's up? What's going on?" And she goes, "Oh, well, now it's so popular now, and so many kids have been busted by faculty and by the schools and whatever, that it's very common knowledge now amongst kids who get it that there are shadow sites, and for a given set of people, there's both a shadow site on web shots or some here or there, a private thing, and they maintain both the Facebook one because they know if they disappeared from it, the parents are going to go looking for them. And so they just maintain these parallel things. And I think this is just the nature of the beast. The people adapt to the social environment that they're within. And if something grows too successful, it's this tragedy of the commons thing or whatever, but it will, I mean, in my view, in that age group or in that world, because you're subject to the man again, I think that's going to be a very dynamic thing. It's hard to unseat the network, but I think that the shape of the network changes, quite a bit.
So how much of a role do you think tools for content creation play? These sites to me seem different in the ease with which
huge, and I have this one that creates spreadsheets and word processing documents and presentations that I'd love to sell you. Yeah, I mean, I think they play a huge role. I mean, my history in this industry, Microsoft's history, is in the computer lib, era where we believe that these are tools of personal empowerment, and we're in an era where if the PC industry started in documents being the thing that was the content of choice that you were doing, or spreadsheets or small databases. Today it's media. We've got digital cameras, digital whatever, and the PC has turned into a digital media, organization and editing device as much or more as it, ever was documents. And so I think it's hugely important. What kind of creation you do is highly personal. Some people are not real extroverts and will not contribute a lot to online forums and will internalize a lot in terms of their nature of participation. And I don't think you can expect that everyone is going to be alike in that kind of, in terms of creation.
Question from Microsoft. So you have talked a lot about how we can collaborate with others, and really there is so much information that we receive every day, right? The blogs, wikis, 100 emails a day. Where do you see us going as far as filtering and maybe prioritizing all that information for us so that we don't spend so much time just kind of like, okay, in the morning, I spend like two hours just checking what emails are important and which ones aren't, right?
Yeah. I'll tell you what I'd like to happen, but I don't know if it will happen. When we were at Groove as a small company, it was 200, 250 people. We built Groove, so we actually were extremely adept users of Groove, and at Groove, I was getting an extremely small volume of email because almost everything that I was doing had to do with some project that was in a workspace of some sort. And I mean, sure, there were people who wrote in unsolicited. There were things related to scheduling. But if you were working on a project, bringing this product to market, doing this design, figuring out the product name for this thing, it's always something that you could spin up something lightweight, do it, keep all the information about that thing together, and then throw it away when you were done with it. Much more effective medium for collaborative work than email, which ironically, it's just so, when I think about email, I think of a funnel. And you start with all these people who are working together on the same project. They share the same documents. They're responding to each other, and they know what context they're in. Instead of putting it into a shared environment, they throw it into a queue where it gets intermixed with all sorts of other garbage, and it goes through this bottleneck where then you have to sort it out again into what is high priority, what's medium priority. In Groove, because the creator of the content pre-classifies the stuff for this project in this tool within this workspace, you could tune your unread marks on a per tool basis. So for stuff that comes in that I don't really care about that's urgent, I just turn it off. And I wouldn't psychologically be drawn to it on a daily basis because it wasn't important to me. I knew people were talking in there, but I'd just go there when I was interested in it. For stuff that was really hot, I would turn it off and have it do pop-ups. And I don't think email gives us, I think the nature of the medium is a difficult medium. So I guess I would just say, my answer is let's move the world toward more of a workspace model if we can. People have tried to put workspaces inside of email, but email's basically, as we said earlier, because of its heterogeneity, none of those efforts have taken off. There was this company called Kubi who tried to create workspaces within within Outlook, but then there were the Notes users and the Hotmail users and so on.
Any more San Diego questions?
Question for Microsoft.
Yeah.
One of the most effective collaboration tool, I would say, is the telephone. And the companies, network companies, have spent 100 years to perfect their network, and it's at a very high reliability today. But in collaboration software, network actually is considered to be a commodity. Do you think when we have more audio and video in those collaboration tools, network will still be a commodity, or will we have some intelligence, some bandwidth reservation, or maybe a parallel network?
This is personal speculation, but I just think the answer is temporal. Today, to use Cisco's new video conferencing thing, you need a 10 megabit link on one provider, on the same provider. Whereas with email, we don't, or with Skype or something like that. So I think temporally, I'll just say, I don't believe in reservations and quality of service guarantees. I believe you throw bandwidth, excess bandwidth at the problem. And I think that over time, bandwidth will get high enough that people will just... I don't think we're going to return to a world of measured usage. I think we're just going to fat pipes.
Question for Microsoft. One of the things you mentioned is that we want to really restructure a lot of the applications that are built so that you've got a local piece, maybe a piece that runs with you, and then a piece that's in a corporate server. One of the challenges, I think, for application writers, whether they're at a large corporation or they're doing small things on their own, is that they've got to learn about lots of different technologies and build up a diverse skill set in order to be successful at that. They have to run operations, they have to host a server, and so on. Do you expect that there are going to be a set of common facilities that service providers can put out there that'll make this easier, and people can just focus on their business problem, and then the rest of the stuff is there already?
Who put you up to asking that question? Yeah, the aspiration is that there is a services platform in the, that I know that Microsoft will provide. I'm sure others will do similar things, but ideally, there are certain app patterns. They won't be the same as the ones that are, on an enterprise server, because we want to probably do limited, more scale-free design patterns for those apps. But I think that a cloud-based computing and storage platform and other things, monetization and so on, will be used in a composite app kind of way by many different classes of apps in the future. So yes.
Anything from your end, Steve?
I think we're good.
San Diego, you good?
Anybody else? I have one thing I wanted to bring up. Oh, wow, is that feeding back? Okay. Have you thought about, and I'm afraid that this might be one of those situations where the difficult problems are social and not technical, but have you thought about technical or technological assistance for group decision making, in particular with groups larger than just a few members who could kind of like sit down in a room and and talk things out. But I don't know about, maybe standards deliberations or even just kind of democracy on a kind of medium scale, companies maybe using it to get feedback from their employees about big decisions and things like that. I don't know.
Yeah, there are people who have done this for many years. There was a company called GDDM, Group Decision. There have been a number of decision support tools that have been built. The one that is my favorite, of course, it's the last one that I played with. There's a little ISV who built a suite of tools that are called the peace tools, and they're used between the Tamil Tigers and the Sri Lankan government. They've been used, and I believe they're still in use, to negotiate peace accords. It doesn't look like it's working really well right now, but it's very oriented toward the language and protocols of such negotiations. And there's a guy who works for the UN who understands the processes, who worked with this ISV to build this set of negotiation tools. But I think it's extremely useful. But I'll say I haven't seen it done yet in a broadly horizontal way. There are decision support tools within the government, within the military, I know. Outside the realm of decision support, one of the first most spectacular failures of software in this realm was a thing called Coordinator, which was Fernando Flores. It was a commitment management tool, but it was essentially email with that tracking your commitments so that it would just continuously bug you. It would apply process onto your email communications, and it was just really tough. Yeah.
Thank you.
Yep.